Welcome back. So in the previous video, we talked about stringing thousands of cheap computers together to handle big data. But how do you actually organize that? If you upload a massive petabyte file, where does it go? This is where HDFS comes in, the Hadoop Distributed File System. So HDFS uses a master/worker architecture, specifically utilizing two types of nodes, the name node and the data node. So think of a massive library. The name node is the librarian. The librarian doesn't actually hold the books. They just hold the master index card that tells you exactly which aisle, shelf, or row a specific book is on. And this is called metadata. The data nodes are the actual bookshelves. They are the cheap, regular computers that do the heavy lifting of physically storing data. Now, here's the catch. Because the name node is the only one who knows where everything is, it is a single point of failure. If a data node breaks, no big deal, we have other bookshelves. But if the name node goes down, you're completely locked out of the library. The data is still physically there, but you have no way to find it basically. Okay, so we have our bookshelves, but big data files are too huge to fit in one shelf. If you have a massive dataset, HDFS doesn't store it as one giant file. Instead, it aggressively chops up into massive blocks, usually 64 or 128 megabytes each. And why chunk it up? Because it allows us to spread a single file across hundreds of different computers. But remember, we are using cheap, everyday computers. Cheap computers break, hard drives crash, power supplies fails, or sometimes a server literally catches on fire. To solve this, HDFS uses fault tolerance via 3 times replication. Every time HDFS chops up a block of data, it makes 3 identical copies of it and scatters them to 3 totally different data nodes. If a server goes up in flames at 3 a.m., for example, the system doesn't panic. The name node just calmly updates its ledger, realizes a copy is missing, and grabs 2 of the surviving copies and clones it to a new server to get back to 3. Basically self-healing. So now, HDFS is, incredibly powerful, but it has one massive glaring weakness. It is built for huge sequential batch reads. It is like a massive freight train, and if you want to read a 10 terabyte file from start to finish to train a machine learning model, HDFS is unstoppable. But what if you just want to find one tiny piece of data? Like if you want to look up a password for user 42, HDFS is terrible at this. The freight train can't stop on a dime. It will have to scan through gigabytes of unrelated data just to find your one row. To fix this, engineers built HBase. And HBase is a NoSQL database that physically sits right on top of HDFS. While HDFS is the raw storage warehouse, HBase acts as the index, allowing you to basically do rapid random reads and writes. You use HDFS when you want to scan everything, and you use HBase when you need to find that one specific thing that you need to find it right then and there. Thank you for watching.